This week on Quality Digest Live, when do ethics come into play when you're 3D printing? When you're 3D printing guns.
Plus, does statistical analysis really help rid us of gut-level decision-making? We'll find out about that when we come back.
Don't miss the largest PC Demus user group meeting in the world. Join us June 3rd through 6th in Las Vegas for Hexagon Live. Hexagon Metrology. We are metrology.
Welcome back to Quality Digest Live for May 31st, 2013. QDL is your weekly look at who and what is making the news in the world of quality. I'm Mike Richmond, publisher of Quality Digest.
And I'm Quality Digest Editor-in-Chief, Dirk Ducharme. Well, we all have electronic stuff, right?
No.
We have our, you don't have, yes you do, you're a nerd, I know you are. We go to our cell phone or our smartphone, or maybe you have a tablet or a laptop. We all have laptops here. So, and we connect to the internet using an internet service provider. So the question is, are we happy with our gadgets and the service that we get from them? Well, the annual report on the information industry sector from the American Customer Satisfaction Index, ACSI, shows that customers are happier with telecommunication services and technologies than they were a year ago. So just to run through some of these, subscription television service entered a 3-year run of stagnant customer satisfaction with a 3% gain to an AXI benchmark of 68. This is out of a score of 100. You can see there on our slide, we got cable was about 63%, fiber and satellite was about 72. People are not overly happy with the level of service they get from their internet service providers, however. That industry received the lowest score of all industries covered by AXI, 64, although Verizon's Fios got a respectable score of about 71. And finally, satisfaction has gone up with cell phone service. Yeah, they haven't talked to me. And apps with the highest scores going to, the highest AXI scores going to actual customer service within stores. So they're talking like the Apple Store or the Verizon Store or whatever. So basically those stores are doing good job with helpful staff and friendly staff. And that's true. If you've ever walked in for customer service for those part, you may be sick and tired of your phone and how your calls get dropped and your apps don't work and your battery life is non-existent. But the service is great. So that's about it. So if you own tech devices, well, there you are. You're probably somewhere in the middle of all that. So,
yeah. Not bad though. For AXI, those numbers are fairly good. We see AXI, of course, in a lot of different industries.
Right, and this is the first year actually that AXI has run on ISPs, on internet service providers. So this is the first year that score has come out. I believe we said it was a 68 or 63, something like that. Pretty low, actually. They do point out that part of the reason for that is I guess this is true. They talked about a lack of competitiveness, and that's probably true because in most cases, you get what you get. You know, you're in a Comcast area or you're in a AT&T. I mean, you don't usually have a choice of which ISP you're going to use. It's whoever happens to service your area. So there's essentially no competition. So that's probably contributing to the lower scores. I mean, why bother?
Yeah, exactly.
Yep.
Thanks, Dirk. Okay. Before I get into my news item, I want to remind you all something. We have a guest in the studio with us today, Eric Perkins, and we're going to be doing a Good Tech Corner here in about 20 minutes or so. If you have any questions about the force measurement system, force measurement in general, or Starrett in general, and you want to ask that question on air, just write us at qdl@qualitydigest.com. We'll get them on the air when Eric's segment is coming up in about 15 minutes. Okay. All right. So also in the news this week, the recent Baldrige Quest for Excellence conference, which incidentally was the 25th in the organization's history, provided, as usual, some compelling benchmarking opportunities. One of the presenters at the conference was Tommy Gonzalez, city manager of the city of Irving, Texas, a 2012 Baldrige Award winner.
Actually, that's pretty interesting. I mean, you think about it. I'm not sure this is the first time a city has won.
No, cities have won several times in the past.
Was Tacoma one?
There was
something in Washington State, I think, several years ago.
There have been several cities that have won. Cities are big organizations. You know, city management is a very difficult, complex a series of processes. So it makes sense that these cities would be winning Baldrige Awards if they do it right, which isn't so easy. And we're going to talk about that here. Gonzalez, again, Tommy Gonzalez, the city manager of the city of Irving, presented at the Quest for Excellence conference, and his presentation offered some really interesting detail on how to achieve organizational excellence not only for those within the governmental space, but really anyone, anywhere. His key message, and it's one we talk about a lot too, communication is a must. You need to build a solid plan based on hard data, you need to lead by example, and you need to respect team members so that they can respect themselves and others on the team, not to mention provide great service to customers. And here's the communication. You constantly need to share information across the organization to make certain that success stories and great ideas are spread far and wide. Again, a complex organization, the city of Irving. A lot of employees, a lot of good ideas are bubbling up all the time. So if you don't share them, if you don't get those ideas from one corner of the organization to the next, you lose them.
It's not going to do any good.
That's right.
And that actually is one of the hallmarks of Baldrige anyways, that information be shared.
Yes,
so.
exactly right. The results for the city of Austin are clear. More than $40 million in cost savings over the past 5 years. Crime is down 35%. And as part of an effort to reduce obesity, city employees lost an aggregate total of 4,000 pounds, saving the city of Austin an estimated $26 million in health insurance costs. That's pretty darn impressive. You know, it's good for the people, it's good for the employees, and saved them a lot of money, right? This is what Baldrige criteria is all about, doing good in a lot of ways. So for more information on how the city of Austin accomplished all of this and more, check out First Win Their Hearts and Minds, Then Consider These Steps, written by Dawn Marie Bailey of the Baldrige Performance Excellence Program. That ran in Wednesday's issue of Quality Digest Daily. The link is just below the player page, right down there. And as always, linked to all the stories that we're going to be covering on today's show can be found right below the video player, again, right down there, so check them out.
All right, well, interesting article this week. Carl Stefan's Printing Guns article.
Yep.
This was basically an op-ed piece by Carl. Just to kind of fill you in, if you aren't familiar, a story that's been in the news is a gentleman by the name of Cody Wilson from the University of Texas, happens to be a law student, has been 3D printing gun parts and entire guns on a 3D printer. That in itself hasn't been so controversial as the fact that he posted the CAD drawings onto the internet so that anybody can download the CAD drawings and in fact print a type of 3D gun or gun parts. So Carl Stefan's article was basically, is this ethical? Just because you can do it, should you? And just so we can know what we're talking about here, Christopher, I think you have a slide there of the guns we're talking about. This is a gun called the Liberator. This is a completely 3D printed single shot gun. This is a very simple gun. This is not a revolver. This is not a semi-automatic. This is a zip gun, essentially. It's a single shot gun. Liberator is, I think he was playing off something that was done during World War II, which was the idea of dropping single shot guns behind enemy lines so that people have access to guns. As you can see, that slide there, it's a very simple gun. There's very few pieces. What do we got there? Maybe, if you can throw that slide up there again.
Not a lot.
Yeah, what do we got there? Yeah, maybe a dozen pieces for a fully functional plastic gun. So Carl Stefan's piece was, do we really want to do this? I mean,
well, and Carl's blog is Engineering Ethics, right? Isn't that the name of his blog?
Exactly, Engineering Ethics.
These are the topics that he's talking about. So and we've covered him on the show before as well, where he talks about, well, you know, we come to a pass now in technology and engineering where we can do all sorts of amazing things, but do we check our ethics and our morals at the door just because we can do something, should we? And that's really kind of his guiding principle in a lot of these pieces.
Right, and you and I did not talk about this piece before. So here is my thoughts on this, and actually this kind of raises a couple, this whole article actually raises several issues. I happen to be in favor of gun control. I don't think outright banning on guns, I'm not for that, but I think there has to be some sort of gun control. But I do disagree with the idea. Now, by the way, I forgot to add, the government, the State Department came in and told Cody Wilson, we don't want you having those plans on the internet. In fact, take them down while we review whether this is even legal or not. So they didn't fine him or anything. They just said, we think you might be in violation of some international laws that have to do with guns and technology, that kind of stuff. So that's our reason, take them down. I totally disagree with that. I think if you have stuff out, and there's plenty of stuff, I mean, you can, by the way, you can do this, how to make a bomb. Go ahead, Google how to make a bomb. I'm sure I did. I'm sure I'm not on DHS's radar anymore now.
No, you have to fly, Dirk, in a few days. Good luck with that.
I've got a feeling I'll be walking to Vegas. But you can Google and find anything on the internet, and that's part of First Amendment rights, as far as part of free speech. It's like, it's a document that's out there. If you don't like it, okay, you can say it's good or bad, but you don't prevent it from being out there.
It's no coincidence that Cody Wilson is a law student.
That he is a law student, exactly.
This is a legal issue. This is, it's an amendment issue as well. It deals with the right to maintain and bear arms, but it's an issue really regarding how you can really challenge the government, and you can just because you can do something, should you?
Yeah.
But this is a tough one, because I could see the other side of it too. How far do we let the government infringe on our rights? And is it's in the Constitution. Should we be able to just freely distribute this information?
Whatever you want, yeah. Well, there's some other issues that have come into 3D printing. 3D printing has raised a whole host of issues, of which this one happens to be the latest, the ability to print things that maybe people would frown on you being able to print it. But there's also copyright issues, and this was something that came up a couple years ago. There was even a conference on it. You can go out, maybe 3D scan a piece of art, maybe a piece of public art, a sculpture, out in the middle of the town square. Well, is that sculpture copyright protected? If it is, have you broken copyright by scanning it? If you scan it and then make little miniature reproductions of it, have you broken the copyright? Well, probably so, but it's very easy to do, and in fact make very accurate reproductions. So the whole 3D scanning, 3D printing is opening up an area of law that I think is going to be really interesting to see what happens over the next few years, because obviously the technology is exploding by leaps and bounds. 3D scanning is getting easier and faster and a lot more accurate, and so is 3D printing.
What about the idea of 3D printing foodstuffs, which is people have talked about? Yeah, you do. Of course you would. But say the foodstuffs go bad and you get sickened by it. Now, whose responsibility is that, right? How about the idea of 3D printing body parts? There's talk of that eventually being able to be.
Well, they are doing it. They're tissue, I think. Yeah, tissue parts. Yeah.
But to actually be able to 3D produce an organ.
Yeah.
For replacement. Technology always pushes the boundaries of ethics and law, and this is no different.
Exactly, and that's exactly why we got people like Carl Steffens, who's always, there's always somebody out there to look at, what are the ethics of engineering, what are the ethics of healthcare and that sort of stuff, and just because something new comes up, it's a valid point. I happen to disagree with him on this, but it is an interesting point to make. So
it needs to be thought of. It needs to be at least considered. Engineers many times don't consider these things.
Yeah, I can build it, so let's
build it. Let's do it, right? We'll worry about the ethics of it later. Well, no, not so fast maybe in some cases. So good article by Carl Stephen. Again, it's below the player page. Check that one out when you get a chance. It's a good read, and you'll learn a lot.
And actually, also just Google Cody Wilson.
Yeah.
If you just Google Cody Wilson and gun, you'll find a ton of stories out there, and they're all actually pretty interesting. It's interesting what's going on with that. So
it is. Okay, thanks, Dirk. Okay, I had an interesting article as well that I wanted to cover this week. It's from Jim Frost, Expanding the Role of Statistics, and that it appeared in Tuesday's issue of Quality Digest Daily. Dirk, as you know, we get these pieces from Jim and a few other folks from Minitab, from the Minitab blog. Minitab blog, a very interesting site. If you've checked it out and you're a stat head like many of us, many of you out there are statistically inclined, check out the Minitab blog, because it's broad. There's a lot of information on there. Of course, it's always statistical in nature, but it ties in a lot of other things as well. And this article is a really good example of that. This is a piece that talks about how statistics really, and statistical analysis really are intended to get us away from gut level perspectives, right? It's intended to get us away from the humanity of having to make a choice depending on what we think is right, and look at what the numbers say. Well, what Jim is saying here is that it doesn't always work that way. We think that the statistics, the models that you create should rule the decisions that you make, but humans are resistant to that, and we'll get into it a little bit and tell you a little bit why that is. Well, we know, and there's plenty of evidence to back this, that predictive analysis models work better than human perspective in terms of making decisions on things. But what many people stop at is they don't understand is that affects even very highly creative pursuits. They'll say, well, things like art or sales, you can't model that. It's got to be a feel. You go with the flow, but not necessarily. And Jim points that out. Some of the examples he uses are wine vintage prices. You think, well, heck, an expert's going to know. Not necessarily. You plug in the right data, and their predictive models will tell you with better degree of accuracy than experts, so-called experts, what price a certain vintage is going to be based on conditions.
Sure.
Interesting. Things like health outcomes. Doctors use a lot of diagnostic tools, predictive tools, to help them diagnose an issue. They're very accurate, and many times they're much more accurate than the doctor's experience and gut level would be him or herself. Things like applicants for jobs or colleges. Again, the thought is many times that the interview is more important. I'm going to tell from how a person is going to perform based on the feel I get from him or her. No, the pen and pencil tests are better indicators of that person's performance going forward than the interview in many cases. And what's fascinating about this, even though the stuff is proven and the evidence is well accepted, the humans that are the customers in these are often not happy with it. Patients really don't like doctors using diagnostic tools. They don't want a computer telling the doctor what's wrong with them. They want the doctor to tell them what's wrong with them, even though the tools are better. Empirical evidence, the tools are better. HR departments, it's crazy. HR departments say, yes, we understand that pen and pencil tools, pen and pencil tests are better than interviews. For most, but for our organization, we do it better. So we don't really trust those. We still trust the interview. So again,
yeah, I think though, I think one thing that's being missed on this is I think because if we're talking specifically about statistics,
yeah.
is so often, and we have a lot of statisticians
Sure.
out there who
yeah.
completely agree with this. Their statistics are so often misused that there is a distrust of them. I mean, Mark Twain, right?
Sure.
I mean,
Sure.
lies, damn lies, and statistics.
Yes, that's right.
It's not that statistics themselves are bad or wrong. It's just that very often they're misused, and so the results are misleading, or even if used improperly, maybe the results are wrong. And so people go, well, wait a minute, my gut's telling me this, and yeah, I know you got all that fancy mumbo jumbo based on sampling, so how can that possibly be right?
Right.
You know what I'm saying? I understand where the distrust comes from.
I do too, but you can't throw the baby out with the bathwater.
Right.
I mean, if you say, well, yeah, our statistics misuse sometimes, sure. But if you don't use them, you don't use the power of the tools that are there to be used. I mean,
right.
Where are you at, right? I mean, are you gonna get a pen and paper out? And you're gonna do long division on an equation to check your calculator?
Right.
Right? I mean, really? Yeah, well, sure. I mean, we have. I guess you can. But I mean, it doesn't really make sense, right? I mean, this really is about. It's crazy. I mean, an example I forgot to mention: script writing. This would be near and dear to Chris Smith's heart. There is evidence that you can tell through plot development points that certain movies are going to make more money. You can analyze it, and apparently there's a guy who's got a tool out there to analyze scripts and say this one's going to make money, that one's not, right?
Right.
Multi-billion-dollar business. All these things come down to psychology. It's the great human brain, right? I mean, the great human brain, which makes everything possible and makes everything difficult. Yeah, right. I mean, that's just the way it is. We learn through pattern recognition. We learn through looking at things and making those patterns and deciding based on that. And again, statistical analysis tools, diagnostic tools, what have you, run counter to that. Run counter to what our experiences tell us that we should do. And it runs against patterning, and that offends us as people, I think, in a certain way. But what Jim is saying is we need to promote this idea that yes, statistics can be misused, as you said, but they're really valuable and they need to be accepted by people.
Yeah, exactly. And I think people need to be shown. I think very often what's happening is people aren't being shown that the results of properly done statistics actually do give good results.
Yeah, they do. Yes, so good story there by Jim Frost. Again, it's right below the player page, right down there. So check it out after the show, please. Okay, we're going to turn now to our tech corner for this week. We're very excited, as we always are, to have a guest in the studio. Eric Perkins of the LS Starrett company is going to join us here in a moment. He's going to be talking about the FMS 1000 force measurement system with Dirk. So guys, take it away.
Thanks, Mike. Yeah, I'm here with Eric Perkins from Starrett, and as we said, this is the Starrett FMS 1000 force measurement system. Is that?
That's correct, Dirk. This is our new FMS 1000, or equivalent of 225-pound test frame, tablet-based, as you can see. Let me go over some of the features that we have here.
Sure.
And kind of give you a little background on what we did and why we did it. Okay.
Okay.
First things that you'll notice is granite base. Granite does two things. One, it gives you a stable platform to work from, and it also provides weight. You're probably thinking, why would you want to put weight to force
you got a
tester machine.
Pretty tall column here.
Well, yeah. Well, it's right. It's because of the column. They tend to want to tip over. The taller they get, the more tippy they want to be. So for safety's sake, we put all the weight at the bottom. Okay. As one of the new design features we did is we did an innovative crosshead. As you notice, the crosshead wraps around more than the traditional comes straight out the front on most force measurements systems. So it wraps around. It gives you a much more stable crosshead that doesn't give you any flex in here.
Oh, it's cool, because with the other method, I'm assuming what might happen as you got to higher forces, the head itself is going to start to
That's correct, Dirk.
deflect.
What you have is you basically got a big C, and then you put the sample in between the C.
Yeah.
And in inherent design, it wants to be a little flexy.
Okay.
So this is the main reason why we did it. Extruded column in here.
So a single piece then.
Single piece column, yes it is. And what we've done on that is we basically put all the electronics in the backside. Makes it very simple and easy to service, and that's one of the things that you want in the field is you want to make sure you be able to service stuff very quick and easy. The ball screw inside is a very high accurate ball screw, and it has no backlash to it. And that's something that you're looking for when you do testing.
Now, just to kind of set this up a little bit here, when we're talking force testing, is it tensile? Is it compression? What
it's
are we
both.
talking?
It's both. This system will do many different things. It'll do tension, compression. It'll do brake testing, cycling. It'll do load averaging, peel test. Pretty much anything you can get inside
just depending on the
anything
fixture.
that you can fit in between these two things, basically you can test it.
Okay.
And that's one of the neat features about the system. As a force measurement system, we offer 4 different style of load cells. So it basically gives the customer the ability to choose what they want to do. For example, if you were doing spring testing, you would not want to go with an S-beam load cell because, as you know, when you're compressing a spring, it tends to want to twist.
Right.
And the S-styles don't really do well with that. So we have a round circular load cell that does that application.
Okay.
Some of the other features we went with on here is we went with rare earth magnets instead of the traditional micro switch for the end limits to keep it from going either all the way up or all the way down.
Okay.
Okay. The entire system is based off a tablet. The tablet's kind of unique into the industry, and no one's done it before. And the main reason why we went with the tablet is most of the people in force measurement, Dirk, are trying to get to a computer. As in your earlier segment, you were talking about statistics.
Right.
They want to go ahead and take the data and they want to statistically analyze the data. Where's my trends falling?
Right.
Okay. With the tablet, I've already can do that. It's dumping the data right into the tablet. It gives me the ability to work directly with Excel or any of the other software packs on the market.
So normally would they do all that with the tablet remaining in the machine, or would they perhaps take the tablet out and take it somewhere, or?
No, sir. It's set up to work directly with the internet. It's got a Wi-Fi. All our tablets are Wi-Fi.
Okay.
Or you can directly hook it to the Ethernet and hook it right onto your network. So it's another computer on your network.
Okay. So essentially, then what you've really done is, rather than have a separate, kind of a big box or even a laptop or something like that, you've just gone with basically using the tablet as a small computer.
That's
and
correct.
also your display. I mean, it's kind of everything in one.
That's correct.
That's the reason for it. Okay. Okay.
So basically, we're using a full USB connection between the frame and the tablet, and we're getting about 1,000 samples a second between the two. So we're getting quite an amount of data that we can analyze and go back and look at.
Okay.
What we've got set up here is we've got basically a standard wire tie that we'd use.
Nylon
wire tie.
Okay.
And if you have a second, I'd like to just go over the front display here to show you what you're looking at.
Yeah, we can go to the gauge cam here.
If you go to, yes. You have the L for load and D for distance. The system will also allow you to measure height, as you see the H come up. So I can cycle between height or distance.
Okay.
The difference between it is, on height mode, Dirk, you're looking at from the bottom up. Okay? So this being your 0 point. On a distance, which is set up for now, I can hit 0 and the distance will be measured from this point either direction.
Okay.
So by hitting the jog wheel, I can make it run up or down.
Okay.
Going over just a real quick test, and this is really the heart and the soul of the system, is how easy it is for people to come in that have never used the system and actually write a program. If I come down here, I click New Test, and I go to Brake Test, because that's what we want to do. We want to actually break this wire tie. It asks me some real basically 4 different things. It asks me some real basic questions. As in any test method, you want to go ahead and zero out your load and your distance because that's where you're starting from. over here where I see set home, I'm basically saying at the end of the test, I want you to come back to this position, okay? Here's our actual test. We have two different directions we go, tension being up or compression being down. Obviously this test is set up to be a tension test, so it asks me a minimum break. And what this is the starting point of where you want the brake detector to start looking for a change, okay? So on this particular wire tie, let's just say 2 pounds. Brake is actually the percent from the max load or peak and how far you want it to fall down, okay? And that means how far do you want it to drop from peak.
Okay.
So for this one here, let's just say 50%, just keep it simple, and we'll say 50%. If you noticed, I'm just inputting this on the tablet on the bottom down here.
Okay, gotcha.
Speed is relative. Most things that you test have a ASTM or spec already written to it, and it tells you what speed you would run at.
Okay.
So for this test, let's just keep it simple and say 10 inches a minute. As I set home up here, I want it to go ahead and return home at the end of the test. So again, it's going to come back to where the set home position was. This is all I have to do to create a test. So you can see.
And you could save that as a test, something you could just recall later?
That's what we're doing right now.
Okay.
So all I've got to do is hit the done button. Okay. As in any standard practice, I want to come up, zero my load, zero my distance. To start the test, I click Start Test. So it's pretty obvious. As you can see, the crosshead's going up at a controlled 10 inches a minute. And eventually it broke.
It snaps, okay.
The wire test. And here's where it was. So that wire tie actually was 40.38 pounds. This is the distance it went, and this is where it broke. Obviously, you noticed when I put in 50%, this is 50% of that.
Okay, okay.
Okay, and that's the drop.
But this is the actual, that top, your M load, that 40.38.
Is the peak load or the maximum load that
so that's actually where it broke?
No, sir.
Okay.
Everything has to go ahead and reach a maximum and then yield. Okay. The only thing that does almost both at the same time is glass or ceramics. But in this one here, it has to yield to break. I can prove that by my graph over here. Here you can see the load being applied.
Okay.
Okay. This has gone from this point here. If I would have returned the test, it would have went back to its original shape. What happened here is it went from its elastic region to its plastic region.
Okay.
And you can tell that by notice the load doesn't go up anymore.
Right. It's because
but the distance is traveling. So that's basically showing you it's in its plastic region.
Okay.
So here was our peak right here, and then you see it starting to tail down as it goes down, and then it drops.
Okay.
So that basically shows you the tail of the tape of what happened during our test. Right. So we went from elastic to plastic, and then it had a long distance in between, and then it started to tail off, and then finally broke.
Okay.
So it's a very nice feature to have on there. One of the other things that we offer on here is we do have our statistics. So it gives us all our data tying into your earlier segment. It's collecting all this data for us. So if we put on another wire tie and ran another test, very simple, quick change. I'll put the wire tie back on. As you notice, it's not
pretty easy. Okay.
Okay. Come back here to my load and distance. The only thing I have to do now is hit Start Test. So it's pulling the wire tie, as you can see. There we go.
And about the same numbers.
About the same numbers, but the neat thing about this is I want to know, is it trending the same as the last one? I can do it statistically, or I can do it the lazy man way and go in and actually go ahead and hit the overlay on the graph. So there's our first one, number 1, and here's number 2. So now I can see, is it trending the same, yes or no? So it's a very easy.
And you could keep stacking. It'll just keep adding.
That's correct. It'll just keep adding another dot and another overlay.
Okay.
And you can really trend it out and see what you're seeing on the screen. So it makes it very, very simple for an operator to quickly see, am I in spec or am I not?
And what's the capacity on this? You said 250.
1,000 newtons is equivalent to 225 pounds.
Okay. And is this the largest unit or?
No, sir. We have 7 different models now.
Okay.
Okay, starting from 500 newtons, which is equivalent to 110 pounds, to our 1,100 or 1,000 newtons here, which is 225 pounds.
Okay. And they're all the same form factor, but maybe a little smaller, a little bigger, that sort of thing? I mean,
up to the 5 kilonewtons, we keep the exact same format, same look and feel.
Okay.
Over 5 kilonewtons, we go into our 10 kilonewton, 30 kilonewton, 50 kilonewton format, which are twin columns. Obviously, the load on a single column makes it flex, so you end up going with the twins.
Okay, gotcha.
So it's really, really a robust design on the single and the twins.
Okay. Well, Eric, thanks. If anybody wants more information on the FMS 1000, there actually is a link on the bottom of the player page there. If you click that, it will actually take you out, I believe, to the landing page for the FMS 1000. I think on that page there's also links to the other models, models as well. So, Eric, thanks for joining us on the show.
Thank you.
Thank you, guys. Back to you, Mike.
Great. Thanks, Dirk. Thank you, Eric. And there you have it. From LS Starrett Company, the FMS 1000 Force Measurement System. Really good tech corner demo there by Eric, with the assistance of Dirk, who's falling all over himself.
Excuse me.
You're so excited, Dirk. Gosh.
That was exciting.
That was a great demo there. No, really.
Hoisted up off the floor.
Yeah, no, good stuff there.
Good stuff. Yep.
We love doing tech corners. We love having guests. Eric, thank you again for being with us today.
Yeah,
and
better than me trying to
oh, Dirk,
muddle my way through it.
But if you have any tech corners that you'd like us to consider for the show, just write us at QDL.qualitydigest.com, and we'll get them on the air for you at an upcoming show.
That's right. Okay, and we are going to be at Hexagon Live
That's right.
next week.
You mentioned walking to Vegas, and with your Googling that you did today, I'm sure you will be. I'll be flying because I have nothing to do with it. But yes, Hexagon Live, that's in Vegas next week. Dirk and I will be there. We're going to do an episode of Quality Digest Live from the show that you can see live and you can see again here on Friday. So be sure to check that out. We'll be there. We're looking forward to being there for the show.
Well, thanks to all of you for joining us, and to Eric Perkins and Starrett for showing up and bringing their equipment.
That's right, their FMS 1000.
That's
and
right.
Thank you to Carl Steven. Thank you to Jim Frost for giving us a great articles this week. And again, thank you all for being there.
That's right.
So have a great week. We'll see you back here with another great week of Quality Digest Daily and QDL on Friday. So have a great weekend, and we'll see you then.
So long.
All right, bye.
Three, two, one, fire!